Hello everyone. So it's a continuation of the block diagram reduction technique video series. So now we are in the before video I just said about like it as a if they are series are there, then what we need to do, we need to multiply. If the parallel are there, then either it need to be subtracted or it need to be added. Right. If it is a feedback loop, then g of s by 1 plus g of s into h of s. That means in the denominator part it need to be multiplied. Right. So now we will see simple examples. Then after that, in the finally, I will give a very complex block diagram to you for as a homework. You need to pause the video and note down that video and update to me. Okay. So now in this video, we just the same reduction of the block diagrams with a series, parallel, and also both combined in examples, not in like it as a only the theoretical format. I will give you some examples because it is a some reduction mathematical based thing. Okay. So example one. So basic block diagram reduction. Let's say it as a if the input is A and after that the feedback loop with B and the output. That's it. There is nothing will be there. If I draw that one in the block diagram, it is the same. So A and a B and nothing is there. Right. As I already stated, this is the sometimes the people will give in a theoretical or a theoretical way and sometimes they will give in a math representation way also. However it will be there also, you need to be understand like what exactly they meant for. So input, okay, input, and after that in between a block will be there, B block is there, and the feedback loop will be there, and the output loop is there. Okay, A block and B block and the output. This is the what they are given. So now how we need to reduce if they see if these two are in parallel. So that means either we need to add or so there is no negative signs other. So I can just simply like it like a plus b, right? And this is the feedback loop. Then automatically what will happen that I need to see whether it is a plus or minus. So according to that one we need to see. So 1 by as it is a feedback loop normally, right? So then what I need to do a by if it is only these two blocks, then I can write it as only this. But what it is going to adding in the one summation block is there. So that means it is like it is a feedback loop. So whenever the feedback loop is there, this feedback loop B will be becoming in the denominator. So that means A by 1 plus AB. The same thing which I said in the before representation like G of S by 1 plus G of S into H of S, where G of S will be the A, here H of S will be the B. Okay, that is the same different thing. There is nothing will be there. Now we will see the complex block diagram. If you see that one, this is the block diagram I gave. Here if you see uh, the summation points are there. This is the summation point, right? I can move the summation point to here. Then what will happen? This will come to this position. Then automatically these two G1 and G2 are in series. Then I can reduce that one. And after that, this will be this point also I will be shifting to this side. Then what will happen, this g2 what are the summation point is that can be come to series, that will be done. And after that this h2 will be in parallel, this also will be in parallel. Then I can reduce that one, and after that according to these results, then I can make the signal like either the plus or minus the summation points feedback loop that will be changed. In this way I can make any block diagram to be reduced. Okay, now we will see what are all the step-by-step procedures for making this to be correct. Because if we say make in between some reductions, it will not possible. So it is having some procedure is there. So first one is we need to make combine first series block. That's why I made first a series block combining, and after that parallel branches. Then after finally only the feedback loops will come. Before we can't make it like this, first the feedback loops, next the parallel, next the series, or first feedback, next series, next the parallel, or first parallel, next feedback, next series, like that. It need to have a step-by-step project to make the system to be without having any differences. The ultimate result always will be the same. Even how much you do in this step-by-step manner, the ultimate result, if you reduce in the normal sense, if you do by the block reduction techniques, both are will be the same condition only. There is nothing, no changes will be there. Now, complex block diagram reduction. Why we need to do when working on a so what if the complex is there, means multiple loops, multiple summation blocks, multiple series parallel combinations are there. Then what we need to do is first eliminate the inner feedback loop. If the any of the inner feedback loops are there, then first we need to reduce that one, and after that combine series and parallel, and after that move the summation points or pick off points. Then finally use the outer feedback loops, not the inner feedback, outer feedback loops. Then you can get a good reduction technique with a less number of steps. So okay. Now Common mistakes, there are multiple common mistakes when you are reducing the block diagram reduction. What are all these means? First and foremost thing, that is the signs. Whenever the feedback is either it is a plus or minus, what it is that we need to see. And the whatever this summation points, and the next is mixing points, feedback points, these things we need to see. Those also need to be very careful. And not applying the Laplace domain rules properly, that is not exactly here. It is in the finally the one things will come, one say single block diagram will come. There you will get the correct one, because here the ABC blocks are there, but when it comes to the reality of the system, you will get the S domain things, or any other domain also will come, like LPF filter, alpha beta. Then automatically you will get the S domain. Laplace domains will be there. So there also you need to be very careful when you are drawing. Next, applications of block diagram reduction techniques. They are used in PID control. As I already said, it's a controller based applications, stability analysis, Simulink modeling, real-time embedded systems. Okay. So this is the example I said to you. You need to pause the video and see there are multiple summation points, multiple feedback points, multiple blocks are there. So this is the best example to understand the reduction of the block diagram. So I need you to reduce this whole what are the dotted line is that reduce to be in only one block and not to be get any other blocks. Okay, finish it and get back to me. Thank you.